So the next talk will be by Mr. Manish Khandagale, and his topic is on accelerating biosimilar development through digital transformation. So fits into the Industry 4.0. And Dr. Manish has completed his PhD in analytical chemistry from the University of Tasmania in Australia. Presently, he is a senior field application specialist and solutions consultant for informatics at PerkinElmer. He is a customer-focused scientific support specialist, enabling analytical R&Ds in enhancing quality and productivity through implementation of advanced analytical instrumentation and software-based laboratory workflows. His work experience spans pharma, academia, and scientific instrument or software industry with a strong focus on separation science. So with no further ado, let's welcome Dr. Manish.
Thank you, Parth. Thanks for the introduction, and welcome all. So we have already heard about different aspects of biosimilars development, and I'm sure today and tomorrow there will be more in-depth talks. I will be talking about the data challenges in biosimilars development. So one way to look at biosimilars development is like a tree that begins with the knowledge of a reference product, and then each part of this tree represents different stages of development as well as the assessment areas. And the fruit that it bears, the quality of that fruit depends on its own inherent biological characteristics, growth conditions, the cultivation conditions, as well as downstream processing. The quality of the fruit from individual tree or individual branch might be promising, but to ensure that you have good harvest, it is important that you apply all these assessments to entire orchard of the trees. And that is required to meet the requirement of totality of evidence to establish similarity between your biosimilar and the original product. And this evidence comes in the form of data. That data comes from many different stages, from upstream, downstream to formulation and clinical studies. These stages involves many different workflows, many teams works together. They use a variety of instruments, different data systems, as Anshuman already discussed about that. The data comes from all different shapes and sizes, you can say, and it generates highly heterogeneous data environment. And so how we can handle these challenges? Throughout the process, you need parallel analytical and biological characterizations. And in whole this process, it goes through series of make test, Okay, so in whole development phase, it goes through series of make, test, decide cycles till it reaches to manufacturing commercialization stage. So efficiency in these make, test, decide cycles determines speed in the development. And we need to handle all the massive data which is generated throughout this process. So we need a unified data management system that can handle all this data, that can enable us to make better decisions. And when we are talking about making better decisions, data-driven decisions, it is important to have access to data that is accurate, it's a contextual, and it's a real time. For example, the sequence activity relationship dashboard, where you can access all the information right from the sequences to individual antibodies and their assay values. You can look at the sequence information to identify potential source of invariability. Then look at bioassay, look at the correlations between sequence and bioassays to identify potential bioactivity regions. This bioreactor dashboard, where you can have real-time access to all the bioprocessing parameters, which you can analyze and apply right control strategies. So when we are looking at this kind of data, it is like standing on the top of the mountain, where you can have better visibility of all the data, all R&D operations, you can make better decisions. But reaching here, it's kind of journey, and it starts right here in the foothills, where very first step is you need to replace your papers, you need to capture all the data electronically in a structured and contextual manner. Then it comes, organize your analysis workflows. It should give more consistent and accurate results. And then all the data which is generated from your capture to organizing these two steps gets accumulated. You aggregate that data so as to make it ready for consumption. You can visualize it in interactive dashboards like what you see here on the top level. So for this journey, you need a connected data system, integrated platform where it can integrate all the processes right from make, test, decide in one single platform. And we can further break it down, these make, test, decide processes into capture, collaborate, compute, publish, and search and analyze. To complete this process, let's start with the data capture and collaboration, which is our very first step. So here you are looking at a cloud-native electronic notebook. This is where you start capturing your data in a structured manner. You can see this is a typical cloning experiment used in antibody development. And different kind of experiments, right from the PCR protocol to cloning and transformation and all these kind of experiments you can capture in one place. You can manage all your materials which you need to perform your experiments. You manage different kind of material libraries, the plasmids and variable chains, and then your cell lines. You can manage all those libraries and reference in the one place. You don't have to go on different sources. Look at the sequence information, or you can bring sequence information from other applications. So it's easier when multiple teams are working on the sequence. You can simply share that sequence along with all the experimental context. In biological workflows, visual communications is critical. You can do the annotations. And as I said, if you have to communicate with your team, and if you have to share visual observations or a sequence, you can share whole this data in a contextual manner along with all the experimental details. So in this case, the cell lines which were developed out of these selected clones were further used for a fermentation experiment where effect of pH on productivity was investigated. And this is the data from a bioreactor. You can capture data here. You can capture all the fermentation parameters in one place. Then the fermentation samples were collected and submitted for different kind of assays like alpha ELISA case, which I'm going to show you here. So samples were submitted for alpha ELISA, and that's how you can manage sample task in one place. Once the sample is submitted for analysis, then we'll move to the compute and publish step. So that's how you can, this was an example how you can capture all your data, you can effectively collaborate and then use that data for more structured analysis so as to get more consistent results. So when it comes to the analysis part, bioassay plays a critical role in biosimilars development. There are many different kind of bioassays which bioassay scientists run, which generates a huge amount of data. And processing all this data manually is a quite tedious and error-prone process. And how we can automate this process so that there is a consistency in data and they can focus more on the science rather than manually transferring that data in the spreadsheets and then applying different normalizations and curve fit analysis and avoid all those errors. So for that, what I'm going to show you is a automated structured workflow which is app-based workflow. Now we all use mobile phones and we talk the language of apps. So how we can build an app-based workflow which can take care of all those sequence of processes, sequence of the steps in processing that data and give you more accurate and consistent result. So here you are seeing app-based workflow built on a TIBCO spot file where you can bring instrument data directly from as a raw data, or you can have that data attached in your electronic notebook in a capture stage. You can bring that data in a spot file interface. Then you have a predefined app-based workflows. Based on your workflow, you can select required workflow, or you can go to the app store and select the apps depending on the steps which you want to perform in processing this data. For example, in this case, for alpha ELISA data processing, I have created a workflow using 5 apps, right from data import to grid plate editor, and then normalization and curve fit, and then publish. So it can go in a sequence of these 5 steps. And once the workflow is set, every time analysis should be consistent. Here it shows very first thing, the data was imported from Envision plate reader, where it brings all the data, do the data parsing, add all the metadata, all the context, gives the plate, defines the plate layout. Next step, it comes to the normalization. You normalize all this data, and then finally apply different curve fit analysis. Here is a 4-parameter analysis has been performed. And once you analyze this data, next important step is you have to publish this data in a central repository, in a data lake here. So all the data, not only from alpha ELISA, all the data from different assays for this particular product will go in one central repository where it will be indexed and made ready for consumption. So that brings us to data consumption part, where without relying on IT resources, you should be able to do Google-like search, where it gives you global search interface, enter your queries, see all the data, not only that particular, all assays and cross-product and cross-referencing data, you can see it here. You can further refine that using simple logical queries and download those results. Once you download that results, automatically it will be displayed in interactive dashboards to give you the information which you want to use to make better decisions. So in this case, this alpha ELISA assay data has been processed, results required data was downloaded. Downloaded data was displayed in sequence activity relationship dashboard, where you can see all this information from sequence alignments to different CDR regions, light chain, heavy chains, and their assay values, different kind of assay values you can associate. Then you can look at the unique sequences and their relationship with specific assays to find if there is any specific bioactivity region. Similarly, for fermentation experiment, you can bring all this data, look at effect of pH on a productivity, the cell growth, and different parameters, the metabolites, and that are generated throughout the process. So this was to give sense that how you can capture data and organize and make better use of that data for interactive dashboards to make decisions. So that, to summarize, that shows how this integrated make, test, decide platform can help you in unifying all your laboratory workflows. It can reduce your time on a repetition. You can reuse your knowledge, can make better decisions, and making better decisions and giving more time for your innovation can really accelerate the speed of biosimilars. Thank you, and please visit our poster, and look forward to discussing with you and collaborating with you. Thank you.